microphone. Okay, now you should hear me. Get this nonsense out of here somewhere. Maybe there.
Do we have anything due in terms of midterm?
We're going to talk about that today. I'll blame you for the midterm. Okay, what's next? Okay, ink. And then super collider. Great. This over here, that's so big. Let's make that smaller. Do away with this. Yeah, I should also remember to default to that. Sound working.
Yeah, sounds working.
Okay. Oh, I opened the wrong thing. View. Post window. There we go. This one. Open that. Close that. Big 7. And get sonic programming. This new, or did I not upload last week? Oh no, I did. Oh, I see 5. Okay, hello everybody. First off, sorry about not getting the videos up sooner. Oh no. Well, that's sad. My coffee didn't make it down with me. I might go get that in a moment. I know. I had no, I'll go get it. Yeah, it's in the yellow thing. I had well check this morning, so I hadn't had much coffee before this class because that just happened. It's this one. Thank you, sir. Sorry about the week. As I was telling people, it's been a cluster. My wife had some shit going on that we didn't figure out what was going on until yesterday, resulting in a very extended hospital adventure / operation. But everything seems to be fine now. So I put the lecture up from last week today, and that's unacceptable, and I apologize for that, but it is what it is. If you did a sketch for today, you can upload it. There's a forum now on that thing to upload sketches. The lecture video.
Or just the whole 6.
Really? You think I closed? Huh? Oh, not published students. Damn you, Moodle. Try again. Great. Thank you. I will be better. I will be better. You're a very kind graduate student. And in other news, faculty evaluations, individual performance reports are due today, so everyone is stressing about getting those in. And there are 2 people in this class likely on committees for nonsense as well, so thank you for your time and effort. Great. So let's get over here and week 6. We're dropping of the sketches. Week 6. Technically on week 7 today. I've been doing it where the sketches go to the previous week. Does that make sense? Yeah. Whoop. Week 7. Grab that. Okay, and should be good to go with sound. Let's see here. Zoom audio, great. Great. Okay, Matthew, you want to tell us anything about this?
Yeah, I guess so. It pans from left to right as you go left to
Mhm.
right with the mouse, but it also becomes higher in pitch on either side as you move it to that side, and it becomes more frequent in the envelope. The y-axis controls the attack.
Yeah. Cool. Let's take a listen. Oh, no. Someone... Thank you so much. No, no, no. It's okay. Mm. Freaking awesome. Thank you, Matthew. Whoa. Danny, want to tell us anything? Always good. Yes. Yeah. So we're doing some like crazy. Oh man. So I literally see the meter going. It's cool. You're playing like frequencies for the dead. It's really lovely. These poor speakers can't do it, but yeah. So tell us, Danny, what's the thought here with the Zom.range? Whoa, Zom.range being passed into the frequency argument for sign-offs. Yeah. Cool. Cool. So let's see here. Zom.range. So we've got an envelope. That's going 0, 1, 0. Oh, a nice long release time. And we're adjusting the first number of it. Cool. Okay. Yeah, sounds great. Thank you, Danny. Maya. Want to tell us anything? Cool, cool, cool. That's how I did class this morning, too. Oh, beautiful. Nice. That's a really cool sound. Thank you so much for that. Cool. Blip has a natural decay to it. If we listen here. Well, here, actually, let's go. We'll just go lower with it. I think like way that it filters out to create this band limited impulse creates artifacts on either side. And so my assumption of what's happening for Maya is that we're hearing that there's artifacts from that. And if we replace it with impulse, which is non-band limited, it doesn't have those same artifacts. And impulse is playing, but we're applying an envelope to it. So we're multiplying this ongoing yeah, that signal is ongoing. It never stops. We're just applying an envelope to it, just like we do for a sign-off. Impulse is the sound we're hearing. And so if I, let's go back to Blip. If I did away with this envelope multiplier, it's going on, we're hearing this frequency change because we're also applying the envelope to frequency. But I also have the envelope applied to amplitude. So we get this decay. Yeah, in two places. Nice job. Thank you very much. Cole, want to tell us anything?
Yeah.
Woof, 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 woof. Lovely. Perfect. We got into some crazy shit. We're gonna get here in 2 weeks, I think. But we're gonna do some of that today. Great. Anyone else? No, wonderful. Oh, Fletcher. Thank you, Fletcher. Fletcher, want to tell us anything?
Nah, I didn't
Cool.
see the assignment. I just kind of had that like made. It wasn't.
man.
really-
Perfect. Love it. Great. Wonderful. All right. Thank you, everybody. Did I miss anybody? Cool. Okay. So today we're getting into synth defs. Let's look at, I've got some nonsense here. So on the GitHub page, there's a couple links for reading that's going to help you out. So again, we're on this big README. I'm updating it every week. The stuff we go through, and I'm going to be better as we move forward about including links. One of the things we want to learn about today is something called synth defs and synths. This is something we've been doing. You just didn't know you've been doing it. A synth. So as an example, here. Notice right here, I'm actually going to s.make. As an FYI, the character S is reserved to reference the SC service. So remember, I mentioned that you can use A through Z as environment variables without having to prepend them with a tilde. Just one thing I haven't said explicitly yet is that the character S is localhost, which is our server. And it means that we can do a couple of things to the server right away. And one of these, this means we have easy access. Server. If I call the window method, it brings up an old school but useful server representation window. This information here is the exact same as everything down below in the bottom right of the IDE. It's just sometimes a little bit more explicit about what's going on. So notice, whoa, that we have this thing called synths. And that actually represents the number of synths actively running. I have right now the output, the meters pulled up, and if I kill this, that's going to go down to 0. If I play this basic synths are active sound processes running on the chip. If we create a basic sine os function and tell it to play, we explicitly create a synth. Now we have one synth playing. If I play a couple more of them, notice we now have 5 synths playing. And if I stop them, then we have 0 synths playing. So we're explicitly creating synths when we're doing the function.play method. So s.makeWindow, if I execute that, pulls up this localhost server window. But just to be really explicit with this, this, whoa. This is the same as that. It's just that this is a little bit more explicit as to what's going on because it actually spells it out for us. Yeah. Yeah, okay, so there's a couple of things. Likewise, we can use local host reference to pull up other useful tools. S.meter, whoa, brings up the meter. Or this is the same as pressing Command Control plus M. Scope, S.scope. S dot. We can also, if we pull up server help file, we can see all of the methods we could apply to the server. We can get all S dot fill in the blank. Yeah. Down here is Gui methods is the ones that we're explicitly referring to. So S dot make Gui. And Gui methods under server help file for more. Anyone remember what does a GUI mean? Yeah, graphic user interface. So it's just a window with some information. Just another highfalutin nonsense term. What is it? GUI, all lowercase. So it brings up our GUIs. Is there anything else useful in here? Make window scope, freak scope. That's the frequency scope that we brought up before. Plot tree we're going to get to later. And then also there's some recording support that you can run directly on the server, which we'll get to as well. Although more and more, I am a fan of just inter-application routing our audio from SuperCollider to a DAW, depending on what you're trying to do. So, cool. Quick recap on the server. So, as I mentioned, this to play, we explicitly create a synth. There are more ways to do this. There's a class called Synth Def. Synth Def is a client-side representation of a synth definition. So there's some nonsense here that you should read through. Open help on Synth Def. Read through it. So the server application uses synth definitions as templates for creating synth nodes. That's a little bit of gobbledygook. Methods such as function, play, etc., are simply conveniences which automatically create such a def. The synth def class encapsulates client-side representation of a given def and provides methods for creating new defs, writing them to disk, and streaming them to a server. So moving forward, this is going to be how I have you create synth definitions. Rather than doing a function in curly cues dot play, we're going to use this synth def nomenclature. It's going to be not horrible. It's going to be not horrible. But there's a couple of things which we have to do in order to make a synth work. So also read through, there's a lot of really great information in here on synth defs and how to create them. So this one is on the web, and as a refresher, because I probably haven't said this explicitly in a while. There's this GitHub page where I store everything. And the main README, which is the front page that comes up, I've been putting essentially the topics that we're going over every week. And what I'm going to start doing is including a lot more readings. And so today there's this reading on the web for synth defs and synths SuperCollider help. However, great question, Charlie, and I'm glad you asked. If we're in help and we go to browse, if we go actually to SuperCollider home, there's a series of getting started tutorial series, and we're going to be reading 10 synth defs and synths. So you can either read it on the web, you can read it in SuperCollider. Thank you for that question. Really appreciate it. Okay. And there's also a number of, if you're feeling overwhelmed, I should have mentioned this a while ago, there's a number of helpful tutorials on getting started. And we're essentially working through a number of those kind of in my own order these first few weeks of class. So a synth definition. let's go through how to do this. Synth Def is the proper way to define feature use on the server. There are advantages to using the Synth Def terminology, which will become clear as we progress. It is essentially no different than using the function play approach. So to do this, we simply declare synth def, and you'll see in synth def help, technically there's a method .new which we could use. There's a convenience. We're just going to use the convenience approach, which is we don't have to include .new. If we just have synth def then parentheses, it assumes that we're calling the new method. Is that clear for everyone, kind of? Some of you who haven't done a lot of programming with methods, I know the whole terminology still feels like I'm just telling you to go whatever to yourself. I'm going to work through it slowly, but just know that this is what we're doing. So we go synth def, then we include synth name, and we can include that you'll see as either a string or a key symbol. Eugen graph i.e. the function. You put the function that you normally would. And so we'll see that, and that's essentially all we do. And then .add as a method, which we'll get to, but that essentially adds it to the synth def library. Yeah. Yeah. It's just extra stuff. And you'll see there are ways. I mean, there's some other methods that you might use. But really, you're going to almost always use new. The difference is some of these instance methods that I'm not going to get into what that means. There are some other ones that we may use from time to time. But again, we're going to pretty much only use .add. So we're just going to kind of skip it and pretend that we're doing it. That this is just, get this in your head, synth def parentheses .add. So my first synth def, I'm actually best to do it this way. .add.
Oh, so synth name.
It's literally how we're going to reference it later.
Yeah.
So keys, symbols. That's it's the name is in symbols in SuperCloud. Oh. Yeah. In fact, I love the idea of cottage cheese. I mean, that'll be confusing. I'm not going to do that. But cottage cheese. Okay, and then within here, we can include arguments. arguments are what we can change when we instantiate a new synth instance. We're going to talk about what that means later. Variables, just like in other functions, variables help organize code. Var. And then the other thing we have to explicitly include always with the synth is out. Must include out ugen in synth defs. Out.ar, we're almost always going to go to 0 until we don't. No, you have to be explicit in including the out ugen in synths. So let's assume something we might have would be freak, and we'll have an initial value of 200. So sig is going to be equal to sign os.ar. We're going to pass in freak as the value. Okay. Any questions? On that at the moment? Yeah, cool. The necessary components, great question. The necessary components, we want to define synth def, and then the name of the synth def. Arguments, what are things we could pass in or change when we create it? Variable is not necessary. Out is necessary, and add is necessary. So 1, 2, 3, 4. And then probably some sort of signal information is necessary, probably. Yeah, so that's gonna become clear in just a second. So if I execute this, we see I've now created a new synth def. It's not playing. We haven't told it to play yet. To play this new synth def, we must call it synth my first synth def. Well, we still have to create a reference to it. But there's going to be some reasons why this is easier in just a few moments.
But
Thus far, we have not covered any new ground. We're just writing things out in a new way.
ostensibly, this is kind of the same thing.
Mhm.
So we can just-
This, yeah, we can do that. You're exactly right. The thing is, you might create lots and lots of synth defs and run out of variables. So this is a little bit easier. This is just a better way to do it. There's also, of course, a help file for synth, which you should read through. Three through. And again, there's some other methods we could apply to this. Where this gets useful is that we can start to there's two reasons this becomes useful. One, in scheduling, whether that's with p-binds, as Cole has kind of tipped us off to, or in routines and tasks, which I hope to get to today, we can create lots and lots of the same version of a synth really easily in this way. Second, when creating complex signal flow, we can start to use synths to create essentially effects chains that we can hot swap in real time. Yeah. Yeah, it's also a way of organizing things to make life easier. There's another instance method in addition to add called store, which would actually write the synth def just to the hard drive of your computer. And then you would never even, in a session, you wouldn't have to actually call it back up again. It would just be ready to go. The instance, so great question. Sorry for being a dick about my terminology. When we have a class, there's something called a class method in which we can apply a method to that object, to the class name, and it does something. When we instantiate a class, we create something called an object. Right enough. Okay, so there's something called a class. A class defines a set of instructions for how to build something. So we could have a class. We could have a class that's just a car class, car. And when I call this car class, I create a car object. So if we're in Detroit, there's car factories. There's a factory that knows how to build a car. A car factory is not a car. A car factory is simply a means of creating the car object, right? So a class is just a means, a set of instructions for creating some sort of object. When we instantiate a class, we create an object of that class type. It's just an object of type car. It could be called whatever we want it to be called. Yeah, does that kind of feel okay? Yeah. Yeah. This is the exact same thing. So now we're starting to create some of those connections for you to the visual node-based programs. So a class method we apply to the class name and it does something for us. It could affect all of the objects. It could change how future objects are created. An instance method we apply directly to the object itself. And it does something to that object. Kind of makes sense. And we'll go over this again at some point in time. But this starts to get to the heart of this idea of OOP. Object oriented. Gosh, my handwriting is bad on the tablet. Programming. So OOP is object-oriented programming. This is a whole method, essentially, of different types of programming languages. How does your handwriting always look so good in Procreate? Just crazy. You practice at it or something? Yeah, that would help. Mine is like this really nasty felt pencil. It's different. Yeah. Yeah. A factory can put out 100 Chevy Aveos. cool thing about a car class is we can create different types of objects of that class typically. So we could have 100 Chevy Aveos. We could also have 100 Chevy, yeah, some other Chevy car. I don't know. Malibu. Yeah. Cool. And there's just then we start getting into parent hierarchy structures where there are different class types that we're not going to get into. But again, essentially they're of the same type of object generally, or same type of class, and they're just individual objects of it. And we can have infinite number of them, and each one is its own unique thing once it comes into existence. Even if we have 100 Chevy Aveos, each one is still a unique Chevy Aveo. We can drive them in different places all over the country. Yeah, it's great. This is good. Go for it. It can. What it saves you is you don't have to define how to build a car every time you build a car. Like instead of having to build a new factory every time we want to build a Chevy Aveo, we have a single factory that can build a bunch of them. That's the advantage. In terms of processing power, I think we're actually asking a different question here, and that really gets to optimizing of the class itself, probably. Yeah. Yeah. I'm really glad we're having this breakthrough right now. Who else? Oh, where can we help you with a breakthrough? Yeah. This is an instance. Yeah. And here's where this gets in this new terminology. A synth def then is essentially the server version of a class and when we call it, this is a server version of an instance or a sound version. It's a specific sound object. That's the server instance. That's the instance of it. Okay, and again, so here we go. Synth, my first synth def. Three. I think this is the right nomenclature. Let's see here. So again, we can use arguments to create unique versions of those classes. Because we might have multiple arguments. And so then we would need to pass in each of those. Now, typically when you define a class in other programming languages, you're able then to assume the number of arguments. But since synth is our class, it's taking in its own set number of arguments. So this is just kind of a weird way that we have to pass in synth arguments. Synth would be the car in this instance. Yeah, exactly. And just like before, with the play method, Yeah. Synth Def. That's where we define how to make sound. And the reasons why this is going to be useful later on is in sequencing, we can use it to create lots and lots of synth objects real quick if we need to. Or when creating complex signal flow, we can hop swap pieces in the chain. Yeah, and this is where we'll get into this, I think, next week. Does everyone know what a bus is? Audio bus, sorry, thank you. Sam, do you remember what an audio bus is? Yeah. It's another one of those terms. It's just like, why? Why does that need to be the term? Can anyone describe for Sam what an audio bus is? Yeah. Yeah. So what's a bus do for us in real life? Unfortunately, get back to car analogies. Yeah. Yeah. So let's say we got our school bus. School bus. And there's a happy school bus driver here. Hey, kids. And our school bus drives around, and then it picks up Sally. And it drives a little longer, and it picks up, I don't know, Romy. And drives and picks up who? Track feet? Track, whatever. Track free. And then it eventually takes all of these individuals and drops them off at school. AKA reverb. Why are you not writing? Wait. School. That's what school looks like. Got a flagpole. You know how it is. So again, it picks up in audio, it picks up multiple signals potentially and takes them all to a similar place. It can pick up multiple signals. It might just pick up one signal. But essentially, it's a terminology for routing audio and typically multiple audio signals to another place. With synth defs, we can use out. And we can specify with this number right here, a bus essentially that we want to send stuff. And then eventually, we could even go sig in.ar bus number and how many channels of audio are on that bus. And then we can bring in, audio to our synth. So we can create complex signal flows pretty quick. Well, you mean properly mixing it, dealing with like gain staging? Yeah, that's when we start getting into audio production. So this class is a weird one because it brings together elements of creative coding and development and computer science, audio and music production, including mixing and mastering techniques, digital signal processing, and composition. And it expects you to do them all together at once, regardless of the background you're coming in on. That's why some of you will hate me at the end of the class, and some of you will have had a good time. Hopefully everyone has a good time, and we all get something out of it. But that's why this class allows for a lot of different backgrounds coming into it, because as long as you have one of those somewhat okay, you can move forward and just kind of pick up the rest. It's hard, I'm not saying it's not hard, but yeah. Yeah, that's fair. That's fair. Forget that guy. Okay. New screen. Refresh that second. Okay. Yeah. Now. Another. Yeah. Synth Def. Oops. We'll wrap it in a set of parentheses, name. Point. Okay. Argument. Freak, and we'll initially set freak to 400. Length. Set to 1. Is equal to dot new. I don't know that we went over on dot new last time. This is the envelope I end up using most of the time because I end up getting tweaky and just want to always define my own envelope. On dot new allows us to say what are our level points of our envelope, how long is the times on each of those, what kind of curves do we have, etc.
Levels.
Amplitude.
Well,
Well, yeah. How many segments are we putting? So in this case, if I go 0, 1, 0, so I passed in an array of 3 points. My first point begins at an amplitude of 0. My second point goes to an amplitude of 1. My third point goes to an amplitude of 0. Yeah. And then I can define the times between those 0.05, which is the attack, and then the release time we'll have as 0.5. Why am I only putting 2 values in on my second array? Nope. Yeah, that's exactly it. Well, what I'm saying is I'm going to go from 0 to 1 to 0. And this second array is essentially saying time. So I've only got 2 time segments to define. Yeah. And then the next thing is curve, and we can actually define curves however we want. So I could say 10, -10, and test.plot. Remember, I can call this, and it shows me what my envelope ends up looking like. Test.plot will help me visualize it, and I can hear it with a basic sine tone. So I did 10, -10. Let's switch them, -10, 10. So those curved numbers essentially can help you define how those linear or how those segments are shaped. What's the question?
Oh, is that looking like
Exponential?
well, is that
Yeah. That's exactly it. If we put in 0, 0, it's just going to be straight linear. Yeah.
I got okay.
So I'll go back to -10, 10. I think that's what I had, right? We get this nice. Oh, fuck. Messed up. Whoa. Right. So good looking shape. Great shape. How exciting. Cool. Now I'm going to say on is equal to on gen dot .kr. I'm going to pass in my envelope. And I'm not going to do anything else for the moment. Okay, so env now used to be an envelope definition. I'm now redefining it. Say again.
So it's on when on
Kind of similar. Yeah, kind of similar. We're essentially defining an envelope of some sort and then turning it into a signal. Cole, I saw a hand up.
Yeah, so you
Yeah, it doesn't negate, it reassigns. So as we're going down, the synth says, okay, I've got a synth definition. And then in 98, I say, you know, I don't need the reference to that synth def or to that excuse me. We have an envelope definition. And then we say, I don't need the reference to that envelope definition anymore. What I need is that definition actually to be a signal in real time. And this turns it into a signal. So I've just reassigned it in the same namespace. No, it's just literally, how would we make this thing? Exactly. It's not a signal. It's not over time yet. If I fired this off right here, so let's assume we'll comment that out. And then again, I was just going to continue with a fairly straightforward example. Sign os.ar. Whoa. I'm going to pass in freak. And I'm going to then multiply by on. And we're going to say out.ar. We're going to send to the bus and we're going to pass it sig. And again, dot add. And if I try to execute this, I get a big error. And it says binary operator failed. We haven't talked explicitly about what binary operators are, but essentially they're UGens that create signals. So I tried to multiply this sign-off signal by something that's not a signal. Yeah, this is a definition, and in 98 we turned it into a signal. If it makes you feel more comfortable, we could go on def on. We could call this on def. So now we're defining an envelope definition. We're turning it into an envelope signal, and then that happens over time. Does that make more sense if I'm explicit about it that way, Cole? And notice now my synth def compiles no problem.
now with the outcome to 0, is that not
Yeah, this is a bus.
no 0? What's the number? That's the ending position or the process?
It indicates the bus we're sending it to. So we're sending it to the 0 bus. Again, SuperCollider is a 0-based system. So 0 is left. What? Yeah, this is not an escape character in SuperCollider. It is when it's in a string, but right now we're using it actually to define a keyword. So the other thing we could do, if this drives you nuts, Bearcats, you can use a different nomenclature. And you can actually write it as a string. No, it turns it into a symbol. You can do it either way, though. And then, again, synth point.
So when you say the backstop has to be-
Say again.
the backstop has to be referenced.
Yeah, a symbol is something we can reference and like it's another namespace. Great point. I want you to notice something. I want you to pay attention right here. Why does that happen? Yeah, what do you mean by that? So how can I clear them out?
Oh, wait, sorry.
Man, period. Yeah, so that clears them out. Yeah. Jared. You can't see my face right now, but it's like, that was not a stupid question. Done action. Done action tells a synth to free itself when it recognizes there is no more signal. So notice on Gen, there's this method called done action. And there's a reference to this thing called done. Some UGents set a done flag when they are finished playing. This UGent echoes that flag when it is set to track a particular UGent. And it has all of these free itself type things, which is nice. Actions, this is what we need. So free stuff to freeze the enclosing synth. 0 does nothing. Notice done action for on Gen is default to 0. Yeah, when it's finished, you'll do this action. And right now, 0 says don't do anything. So done action 2, again, done action 2, free self, free the enclosing synth. Now, if we and it works itself back down. So we don't have that buildup of resources that'll eventually get us in trouble. Done action 2 tells SC to free the synth, and there is no more synth. Yeah, 3, 4 don't do, they do different things. They go on to next or previous. You're primarily going to use 0 or 2. 0 does nothing. In this, so it initially was 0, and that's what causes us this huge buildup. Hangouts, even though they're making signal that's just zeros, they're just producing zeros at 44,100 hertz a second. Here?
No.
Yeah. Okay. One other UGen to look up, I believe. Let's see here. Oh, yeah, that's exactly it. So there is another method if you ever wanted to worry about this called free self, which will try to track signal, and when it goes to 0, then it frees itself. But it's just better to use the done action in the thing. Cool. Okay, and then finally, we also included this argument length. Let's go back and use that. I'm going to actually copy up above, and I'm sorry about that. So notice we haven't used length yet. One of the parameters we have for onGen is timescale. The durations of segments are multiplied by this value. This value can be modulated, but is only sampled at the start of a new envelope segment. So that's one way we can affect the length of something. The other thing we can do, though, is we can actually say on an array, oh, what is it? Hold on here. That I'm thinking that normalize array. No. Sorry, hold on a second. I need to. Well, so there's a couple of ways to do it. Essentially, I'm trying to say, how can we change the length in real time? And there's two ways to do this. One, we could say, if we set this as a percentage of 1, so let's say we set a percentage of 0.1 and 0.9. Then we could pass in here time scale length. And then when we call it, it's 1, it's 0.1, it's 4, it changes that time scale for us. And you can start to imagine there's many ways of doing this. So this is one way of doing it. What's the question? Yeah, I don't quite. No, it's okay. Try again.
Okay, so time scale, is there kind of a general, like, is it kind of like you talked about like one?
No, yeah. 1 is the normal amount. So it multiplies it up or down by that value. So if it was,
So if we didn't specify it, would just
yeah,
and if we specify 2, it would just go.
yeah,
And you can't go below 0.
you can't go below 0. So one thing I'll often do is I'll just specify, if I'm doing it this way, I might specify length minus my other times up top. And then my attack is always the same, no matter how long it is. Yeah. Yeah. We could also specify different. We could say, what is our decay length? And then just pass in decay if we're not worried about the total time. Right. So this is where you start to have to be flexible in the way you're building these things to do what you want them to do. The other way that I was thinking initially, we could pass in 0.05, 0.5 dot normalize sum. So notice if I normalize sum on this, yeah. So it essentially makes it so that it equals 1. Now in this case, 0.09090909 plus 0.9090990 equals 1. Because we told it to normalize so that each value sums to 1. Well, let's do this down here. So we have a 1, 4, 6, and I say normalize three of them combined. Normalize makes it so that everything is shifted down essentially between 0 and 1. Normalize sum, again here, array, normalize sum, returns the array resulting from the array divided by the array dot sum. Typically, we pass that in as just 1. No. What does normalize do in an audio file? Anyone else? No compression. So let's say we got an audio file. Come on, why is that hotkey not working? So Charlie. It's close, it's close. So let's say we got an audio signal here. You're all on the right track. We got 1, oh, come on, wait. 1, -1. So 1.0, -1.0. And our audio file looks like this. Okay, and we've got a peak of, let's say, 0.8. If we normalize that, we say that we want to normalize to some value, typically 1. So what we're going to do is we're going to say, what do we need to do to every sample in this audio file in order to make a peak value of 1? So how do you make 0.81? How do you do it through multiplication and division? (0.8) divided by 0.8 equals 1. Yeah, sure. Yeah, we're changing the dynamic range. So we're going to take every sample and divide it by 0.8. We're just going to bump everything up just a little bit. So normalize takes an audio file. It doesn't compress it. It doesn't change the dynamic relationship from the quietest to the loudest moments internally. it just sets it either up or down to some pre-specified level. We could do the opposite. We could have, or the same thing, where we've got some sort of audio or some sort of signal that goes to like 1.4. Whoa. And we want to normalize everything down to 1. We divide everything by 1.4, and it's going to bring every sample down by the same amount. Yeah. So let's say we've got an array and it goes 0, 0.8, 0.6, negative 0.6, 0.2, negative 0.20, something like that. And we can plot it. Cool, we plotted it. That's cool, right? We see where it goes to. Now, if I take this same array, so we're going to say, that's our array, a dot normalize. We'll store that in the letter B. So we see these new values. Notice what's our second value. It is 1. It wasn't still, it was 0.8. So it raised everything up by the same ratio so that now we go to 1. Say again. Yeah, but that depends on loudness too. I don't know the algorithm. It could be what it's doing. It could be what it's doing. Yeah, Jared. So SuperCollider internally is actually fairly forgiving about going over 1 or going above, essentially that is 0 decibels full scale. We're in decibel level. SuperCollider is very forgiving and gives itself a ton of headroom so that you won't distort too much. Where you need to be considerate of it is on when you actually either write to disk or record a file or you go out of the speakers. When you're in digital land, you can be pretty flexible because it's all abstract anyway. When you get to physical land, that's where you start. You can't make a speaker go louder than 1. I mean, you can't digitally make a speaker go louder than 1. If that makes any sense at all. Yeah, cool. Oh, sorry, Jared. Yeah, I mean, and what does? Oh, I don't know. Fuck Logic. I don't know Logic. That's not my jam. I'm either in Ableton or in Pro Tools. If we're in Pro Tools, let's see, do I have any? Huh? Yeah. I don't know. Yeah, I kind of agree. Ableton's great. We got, for anyone who's working on these computers in here, we've got Ableton and Reaper on these computers right now. Yeah. 9, whatever the, not the most recent one is. Yeah. I need to pay for updates.
Well, with anything, like if I try to drag the like audio segment
Oh.
to a certain bar line, it'll zoom in. It will not be perfect.
All right, we're getting off track, and that's my fault too. I'm so sorry for everyone in here. Let's I would love to have a vigorous conversation of DAWs over beer with anyone who's interested, but it's not for our moment here. Okay, so let's take this same value, a dot normalized sum. Yeah. You're going to peak up to whatever the specified is in audio. Or you might pick -6 decibels so that you've got good gain staging before you start mixing. Just to set peak level relative to everything else in the file. And normalized sum is how we actually do it in audio. Notice here, our second value gets popped to 1, and then everything else relatively stays the same. So again, normalized sum shouldn't be right. I think it just must be because of the weird numbers that I plugged in there. Yeah, there we go. That changes it all up. So normalized sum, actually ignore the previous statement, but normalized sum is trying to say, how do I change this so that everything in the array equals 1? Anyway. Yeah. Now everything equals 1, and I can multiply it by length. Doesn't. Just whatever difference it makes in your head. Yeah. Yeah. That's what is happening here. It just depends on how you like to look at it. It's coding language. Whatever makes sense to you and is more readable to you is what you should do. When there's multiple ways of doing something, if you're on a team, you follow the team protocol. If you're on your own, you do the thing that makes the most sense to you. Cool. Okay. 11:25, 15-minute break. Hey, it happens. Oh, no, yeah. You doing okay today? Yeah. Yeah, I understand. Yo, you want to put it here?
I just having like a quick problem with like first example. It just won't. I keep being like this thing right here. I'm not like this would be like a on it.
So did we execute? So I think what happened here, this is very common. You hadn't actually compiled this. Like literally, I have done that thousands of times. Be like, why? Watch it work. Please work. And I just forget that I never actually told it to go to the server. Hey, easy mistakes are way better than hard ones. At least then you don't have to actually have a hard time problem solving. What? No, that's not good. It's just not doing it for you today. Bummer. Yeah, right. Is there a water fountain in this building? Charlie, so sorry to interrupt. Is there a water fountain in this building? No, neither. Yeah, yeah, I think he's. No idea. Yeah, I think unfortunately that's true. Did I say 25? Is that when we split? Has it been 15 minutes? It's been 15 minutes. Let's get going. Okay, let's do things in time besides just make signals. It's time. Okay. So obviously SuperCollider has a clock going on because that's how we're able to do sound. Sound is uniquely and intimately linked to the passage of time, right? Sound does not exist. It's not possible to have sound not related to time. Cool, cool. So obviously one of the things we can do in SuperCollider is we can tell it to do things in the future. So there's this thing called system clock. Clock running on a separate accurately timed thread. And system clocks allow us to schedule things in the future or to do stuff in some sort of time-based system. In this example, system clock.schedule 5 hello.postline. I'll execute it. Hello, 5 seconds later. Cool. Command D on Mac. And if you're on a class or some other thing, you'll try to go straight to that file. Otherwise, it just goes to the main help window homepage. Also, as with most things, applications, there's a way to do it up here. Maybe under help. Show help browser. Yeah. Cool. So we can obviously schedule things in the future. Cool. Yep. We can also do something called forking. So let's look at array here. So fork used within routines and assumes an array of functions from which subroutines are created. What? Subroutines are played while the outer routine carries on. The join parameter expresses out after how many subroutines. So much craziness. Let's just do this. We can say I think we can do something like this. Oh. I don't remember. This is really not something I've done often. So I'm just gonna. Right. Hold on here. Trying to remember this. Array, show it to me. Yeah. One more. Well. Oh, it has to be a function to execute. So that do it. Hey, isn't this embarrassing? Super cool. Wait, let's look at it. We'll figure it out here. I haven't done it this way in a while. For.do. Let's build it out. Okay, that's our function. That do we know. Oh, now I remember what's going on here. Okay. So this is one way. We're going to look at another way, though. That's going to be a lot nicer. So for.do. Working. So we've got this nested structure. So for.do, if we look up do on an integer, executes function for all integers from 0 to this -1. So if we did away with one.wait, hold on. 3.do, not 23, 3.do. Keys function. Print this. Print this 3 times. Okay. A is equal to 0. A is equal to itself plus 1. A dot post line explicitly. Binary stream operator, you jerk. A, because I never executed A. There we go. 1, 2, 3. If I have it set to 30, whoosh, what? No. So what we're doing here, semicolons tell it that it's an end of a statement. So don't technically need spaces. I put in lots of spaces and new lines to make it more human readable for myself and for others. Do as a do loop, essentially. Yes. Be like that. We could have this whole statement be right like this. And it's going to do the exact same thing. Spaces don't matter. Nothing matters. Yeah. Semicolons matter a lot. Damn semicolons. Who knew we'd be ruled by semicolons? Again, I don't like this. This is not as human readable to me. I like spaces. I would typically space the function. If I was doing it on a single line, it might look like this. Oftentimes, I mean, you know, this is nice to do on a single line because it tells us we've got a function. We're doing 2 statements per function. Again, going to print those out. And we're building up numbers now because I haven't reset A to 0. As soon as I do that, same thing. Yeah, if it's on the same line. So do something, some specified number. Okay, so then if we've got 3.do, we can pass in a function. And in that function, we might, we've got boink, I think already, synth. Boink. I'm going to say, I want to wrap this whole thing as a function, which gets confusing. I'll admit, but it's not the greatest way to do it. And in SuperCollider, if I could grab a whole bunch of stuff and I hit tab, it automatically indents it for me into a nice nested structure. So what happened there? Made a sound. Watch this group 1 thing. So we had 3 for a moment. I did 30. We had 30 for a moment. Let's look at dot fork. So we're going to open up preferences. What do we have dot fork applied to? What are semicolon or what are curly Q brackets? A function. So we pulled up help and we're going to look at function. Returns a routine using the receiver as its function and plays it in a tempo clock. Oh God. Okay, so the receiver is whatever's inside the function and gets executed. In this case, we passed in a do loop as Bearcat helped us remember. Notice they've added this thing called one.wait. Let's look at what wait does. Whoa. We'll go over here. We'll add one.wait. We'll spell it right. And simple number, Within a routine, yield the number so that the clock can wait for this many beats. Outside a routine, this throws an error. Oh, that's a fun mistake. So here's an example. Yes, it did. No, you didn't. Yes, it did. No, you didn't. Yes, it did. No, you didn't. Cool. So we've got one dot wait fork. One beat in between each one. 1 second, 1 beat. We're gonna get to that. Good moment of seconds. Cool. Great. And we reinvent music. Right? So why did it stop at 30? We only run it 30 times. If we want it to run forever, we can do something in. So you can start to see though in Superfighter how you can fuck around and start to how you can play around and start to quickly live code music, sound, art, whatever you want to call it, by just changing a couple things and executing them pretty quick. Now, the other thing we can do is we can actually wrap this function, or we can assign it to some sort of reference. I think it's start. Nope. Play. Oh, but it doesn't. That's right. It doesn't. Routines are not cool like that. All right. And anyway, so that's one way of doing something. Let's be explicit here. Go. So we're going to open up help on forking. We know it's attached to a function because of the curly cues. Returns a routine using the receiver as its function. We don't know what the heck a routine is yet. Functions that can be written in the middle and resume where they left off. The routine runs a function and allows it to be suspended in the middle. It can be resumed again where it left off. The important part for us is that when a routine is scheduled on a clock, it will be started or resumed at the scheduled time. So routines relate to clocks. So in this case, routine execute over time. Assign a function to the variable A. Do something for infinity. Execute. Operation. Pause. Okay, there's some comments in there. Hopefully that helps. Again, that's a lot of comments for something that is really quite simple. Tell me.
I thought that the closing parentheses. The closing. But I thought the closing parentheses ended for. Ended for. So why do we do a stop?
Because we've assigned this routine to the environment variable A. We're telling it to stop that routine. I executed it when I wanted to. No, it's okay. Totally fine. So let's look, task is the one though that's going to be a little bit more useful to us. And yeah, tell me, Matthew. Fork creates a routine. Okay, number 15. So sorry to be so dense. My fault. There's this thing here, sequencing and routines and tasks. You should read this. It'll be helpful. Routines can be used for data processing. So it's gonna talk through a lot of this in very specific detail, but essentially a routine is some sort of process that we can start, stop, and work through. We can use it to play sound. We can use it to do some sort of other scheduled set of tasks. We can use it for some sort of ordered set of operations of functions or other commands. So in this case, let's come over here. Yeah, well, you will. Maybe. One day. Thanks, our tutorials. And okay, so executed a routine, assigned it to the letter R. R.next prints out ABCDE. R.next FGHIJ KLMNO PQRST PVWXY Z bracket line bracket tilde. No, there's nothing left to do. If we re-execute it, we can do them all at once. So it's just a set of instructions.
So what is R equal to?
There's nothing left in routine. So R nil is telling us I don't have any more instructions.
So R is
Say again.
nil.
No, it's different, but R is equal to the routine. We're telling R to hit its next step in the routine. Yield tells us to wait after command. So if I did away with this, I didn't even notice this as a command. Oh, if we did it this way, dot post log. Okay, clear the post. Notice we've got a routine. R next. So it printed ABCDE, and then it went straight on to FGHIJ, and then it yielded. KLMNO, when I hit next, is going to get printed, and then it's going to go PQRSRT, and then it's going to yield again. Pause. Yeah, stop sign. That's exactly it. Stop whatever you're doing. Huh? Drop it. If reset it, so first time ABCDE, and then we get this thing to yield. Next time we're going to get 1, 2, 3, 4, 5 KLMNOs posted before it goes to PQRST and then yields, right? Oosh. Come on now. So we can use routines. In this case, we're creating a routine, assigning it to the environment variable R. We've defined a variable delta. Delta in many algorithmic contexts relates to time. So we're saying create a loop in our routine. Delta will be random every time we go through this loop. And we'll wait. So if I execute that, we've got a routine. If I hit r.next, we'll wait 0.5 seconds. We'll wait 1 second. But I can just keep hitting next. However, we assign routine to a tempo clock. Yeah. Again, though, this is a little bit more high level than we necessarily want to be. So we're just going to move forward to task because this is the one that's a little bit easier. So, same thing here. Whoa. Let's look it up. Loop. We had it attached to a function. Repeat this function, useful tasks and clocks. Okay, you're right. No, Matthew, that's a great point. So there's this thing that gets confusing, and I forgot to mention this. There's two ways of attaching a method in SuperFighter, which makes you just want to punch someone. There's leading and there's trailing dot method. In this case, we're saying loop this function. That would be no different. Let's copy this as an example for a moment. So this would work. Oh, great, it doesn't have synth, that's fine. But this is the same as writing. Tied to dot. Yes, it can be if they're. Yes. Mm-hmm. No, it's just literally which one is more human readable. Yeah, I know. Okay, so task. For the time being, I just want you to think about this. Tasks are like routines, but that. So, let's do this. View the task. And we pass in a function. And so we're going to say int dot do. And we're going to say yo. Fine. Wait. So in this, we've defined a task. We've then defined a series of functions. And within those functions, we have a wait or yield, same thing. Now, this doesn't look very clear. And this is why sometimes writing loop works better for some people. Whoa, that should have been the same thing. I've got an extra trailing. Okay. So loop will do the same thing, and we'll use that for the moment. And this is something called receiver syntax versus trailing syntax, something like that. At any rate. Yeah. For where? Because really it's this. Yeah, it's a function method. It's not a symbol for something else. It's telling us to just loop this function over and over again. It's just a symbol. It's a great question. Let me think about how to better explain that. Cool. Can you send me an email about that, and I'll get back to you next week for the whole class. Whoa. A task is a set of functions. So I was just about to show that. So we've got tasks are more flexible. That's why we're just going to use tasks for the time being.
Yeah.
At the moment, yes. Oh, oh. Well, so we're defining here a task. We're passing in something that we're going to loop over and over again. And then we've got a set of instructions in that loop. This is useful for something. Let's say we define a synth def. In this case, it's just simple sine wave. Simple try. Oh my gosh, come on, fingers. And we'll pass a reference to this. What in the? Oh yeah, we can do triangle waves. Did someone say we couldn't? Oh yeah, there's all kinds of stuff we can do.
Well, I figured that the sign was like,
Quits. Ooh, why didn't it? That's not the wrong thing. Oh, okay. What's going on in Zoom line? Is anyone? Okay, well, audio built in. What happened to the big now? That's weird. Cool. Okay, let's try this again. Cool. And oh. And we're gonna set this like it's pulse. We're not there at the moment. Okay, so now we're gonna take a task. And instead of doing something like this, we're gonna say try.set freak. And let's say we haven't gotten into this yet, but we're gonna go 200 to 2000 rand. So let's look at what rand does. Simple number. A random number in the interval of A to B. So in this case, we'll post that every time. Whoa. Where's my error at? Oh. Sorry, tried to do something I shouldn't have done. Let's see this. Variable freq equal to rand and the value of time. Okay. Great. So let's talk through what's going on here. Define a simple synth. Play the synth and store reference in try. Define task. The tasks function is to set this synth. So then in this function, we've got a variable freq, and every time it's executed, we grab a new random number. Sorry, let's use dot receiver notation. That's between 200 and 2000. And again, we see in simple number, a number and upper limits. If it's a number interval, it gives us a value between the two of those. We then pass that in to triangle and set the frequency of it. And then we wait 0.5 seconds. Oh, it does not like that dot receiver notation for some reason. That's fine. Whatever. We'll do the front. It's our rand is the function direct. We play it. Likewise, we could say wait, or we'll use the nomenclature delta, which I like quite a bit. Delta, same thing, is equal to, let's say 0.125, 0.25, 0.5, 1. I think we can do choose, is that right? So this will grab every time a random value from this array. We'll say delta. Wait. Yeah. Oh, I got to play my task. Here it. Yeah, as an integer. Stands for range. Yeah, for some reason, I don't remember why. I thought you could do that. But yeah, so you could actually just go. Well, the easiest thing to do. Yeah. Cool. Yeah. That is an environment variable. global variable. Essentially, I can define it and use it anywhere. Just like A, B, C, like we've been using those. This tilde gives us the tilde is the name of the character. It gives us the real the define an environment variable. Yeah. Yep. Yep. Okay. Yeah. Cool. Likewise, if we've got similar thing, we can do this, and instead of setting something, synth point free. Free. And we'll move this up. And we'll say length. Length is equal to delta. And we can, of course, start this at the same time. Yeah. Great thing about doing it this way, rather than just setting like individual synths, we can have the synths overlap with each other. This is essentially the equivalent of an analog syncline of going from a monophonic synthesizer to a polyphonic synthesizer with multiple voices. This is changing the length of our synth, in which case, remember, was affecting how long the envelope was. Yeah, but it doesn't affect the wait time. That second. Yeah, makes sense. So we can have this just be set to a hard number. We can build up better sense. And then the other thing, just to be explicit, yeah. No, you know what? Let me not be a jerk. It is also a function. Instantiate a new synth. Specify. Yeah. Okay, let's see what we're working with this. So here we're going to actually, yeah, sure. You can, in fact. there's two ways of doing that. There's one way where we would say something like 60, 62, 60, or I think I remember 65, 67. Nine, 21, 22. Cool. And we could do something like freak is equal to freak sub IDX, which you don't know what that means at the moment. That's okay. Yeah. And out here, we're going to define an index value. This is probably not the best way to do it, but this is how we're going to do it for the moment. And then we're going to say index value is equal to index value plus 1. Right? Say that again. Line 128. No. What happens? Yeah. So this is an array, and we should be more explicit for the time being. This is not proper way to do this, but that's okay. So we define an array, and then we say here, grab the freak array, grab an index out of it. And then what we should do next is say IDX is equal to IDX mod array. Oh, did not like that.
Oh, wait, so the IDX number just counts what order of the array?
Yeah. Oh, modulo. How many people are familiar with that? Jared, you got a question? It's choosing one of these. So we could say it's either going to be quarter or half.
One of those on line 141, it's taking and then weight becomes a method of delta. Delta is
What is delta? Well, what is it? It's just a number. So it's some sort of integer or some sort of float.
Right. I guess I would expect
Yeah, it does. This is one of these fun things with supercollider that makes people want to kill it. I don't disagree. This is where, Bearcat, if you read this, it talks about this idea of yield, and then down below, how yield is the same as width. but it talks about this control structure and how it's using. And so again, that is in the GitHub. Read these two sections, 14 and 15. And hopefully that'll help. Just a couple more things to be explicit about here. Is equal to tempo. Well, plus two, I think it's not actually BPM. So if we want to think in actual BPMs, it has to be divided by 60. Otherwise, you're saying, what's the inner onset essentially between these in terms of seconds? We can think in seconds. Two different ways of doing the same thing. We're going to use sample clock for time. Cool. Yeah. Yeah, because down here, I did this real quick and sneaky. We're saying take this MIDI number and convert it to cycles per second or hertz. Dot MIDI CPS. Should have been explicit about that. Sorry, we got confused on a couple other things. And then I just, Okay, and one more thing here to be explicit about that's cool. So notice it's worth reading through the task documentation. Oh no, it's not worth reading through the task documentation. It's worth reading through this documentation sequencing. Because it shows us something a little bit slicker than the way I'm doing it. In this case, we're looping and we're creating a set of functions, remember? So if we have for.do, it says do something 4 times. If we have .do on an array, we're going to pass in each of these values as an argument to this array. Now, what doesn't feel good in the way they have this written out is there's one more thing in super collider that causes confusion, because there's another way to do things multiple ways. You can write pipe argument name, or you can write argument and then specify the argument name. This rather equals no. So this is saying this syntax right here, when you have it between pipe, is saying arguments.
Yeah, so you can do that.
Yeah.
Okay.
I don't like it because I don't think it's explicit enough. I like to write the keyword ARGR. Yeah, you could. So, because it also passes in an index. And so we could print both MIDI.postline and IDX.postline. Oh, but we need to define our synth here. Which they do somewhere in life, synth sign grain. One second, Cole. I see you back there. Wait. I'll get you one of these. Okay. Oh, let's go back to. So notice it's printing, and let's be even more explicit. You'll see 0 is 60, 1 is 62, 2 is 64, etc.
Okay, and our MIDI and IDF.
If we look up the do method for an array,
Yeah.
we'll see that it iterates over the elements in order, calling the function for each element. The function is passed two arguments, the element and an index.
Does that have to be IDF? So it needs to-
No, we could call it whatever we want. We can call it I, we can call it hey.
But the first thing that and the second one you need to
Yeah, the function is passed two arguments, the element and the index value.
and if you added a third argument, it would be
It won't be anything. Sure.
but you need those first two arguments.
No,
And then what happens if you got rid of it?
if we got rid of it and then we just pass in a value here, 60. It's still running through the array. It's just we're not using those arguments. What do you mean? Well, it's just telling you whatever, it's playing whatever I told it to play.
Oh, gotcha. It's not used.
It is, we're just not passing in the arguments. We're not passing in any data.
Okay, so
We weren't using the data. That's what they're doing. So we're passing in MIDI as a value. And then we're passing in, we're creating a new synth with that value. Ah, maybe I can help out with this. Maybe not.
this is just automatically.
Yeah, and that's what the help files tell us. This function is passed two arguments. If we call do on an array, which is what we're looking at right now. So notice we've created an array. And arrays in almost all languages are always specified with square brackets. So we've created an array 60 containing 1, 2, 3, 4, 5, 6, 7, 8 elements. And we're passing this do method to the array. And if we look up do for an array, it tells us iterate over the elements in order, calling the function for each element. And so we know the first argument we're going to pass to do is a function. This function is passed two arguments, the element and the index. So if we define an argument, two arguments, we can call them whatever we want. They're going to get passed these two elements from the array. Yeah, and no. Yeah, you know, again, well, tell me what you mean.
Well, I guess, so if it's using the first two to specify, if it's kind of, it's saying that the first two are mine, it's saying, don't use these, these are mine. Can you still add, like, if you added a third one, that wouldn't have anything to do with function,
But it's not going to get past anything through this.
but you could still use it, right? For example, if you added a mole argument.
And I would actually say we actually define a variable called mole.
But
And then mole, yeah, and then mole can be anywhere from 0 to 1. And then instead of amp, we pass in mole. This function will only receive two arguments, the index or the element and the index number.
Right now,
Yeah. Yeah.
Okay. But you can specify
Here's the important piece, is that mole is nil. It's not getting past anything until we set it. We didn't set it. And that's why it's better to think of this not as an argument, but as a variable, Because this function, an argument is something that gets passed in from another place. That's the important piece here. An argument is something that gets passed in externally. A variable is something we set and play with internally. Yeah. Yeah. It's not a pipe function or pipe method. It's just the character. I don't know what the heck that line is called. Tall line. It's just another way of writing R. And the reason I bring this up is that the literature in SuperCollider and SuperCollider users go back and forth depending on the user. So you want to be familiar with both of these syntaxes. I don't like the pipe. I think it is not human readable. These two lines, 166 and 167, are equivalent. Yes. SuperCollider is known for being an idiosyncratic POS with lots of ways to do the same things, and it turns lots of people off that because of that. I'm not going to disagree. It's not the prettiest language. It's just downright ugly. POS. Yeah. That's exactly it. Well, that's why you would define team-based syntaxes. Cool. Yeah. You can execute system level commands in SuperCollider. That's the more significant one. That's not going to happen. If you import a whole bunch of code and it's got some sort of really gnarly looking URL, I wouldn't execute. But that's not going to happen. GitHub. Oh, and I never did that GitHub thing. Man, this semester is killing me. I'm failing all of you. I know. Thank you. Thank you, wonderful graduate students. Okay, here, hold on. Go backwards. Okay, so here's where we're at moving forward. We're going to launch a project here in a second. We're going to edit it. Next week, we're going to talk about how to get audio in. So we're all going to do lots of feedback. It's going to be super cool. I'd really encourage you to bring some headphones. You don't have to, but we'll all be happier. And then we'll talk about how we can do signal processing of input signals or of other signals. And that's going to bring us to my favorite set of UGens in SuperCollider, comb UGens. We'll talk about those. Gosh, and this feels a bit aggressive, but we're going to do it this way. We're just going to stick with it. So we've been doing daily sketches. It's cool. So next week, we're going to look at some sound in stuff. Week after that, we're going to do our first big critique day with midterm projects. It means you're going to compose or create some sort of music and or sound art piece. We're going to go into the studio. I might bring better speakers in here, and we'll listen to each other's pieces and really talk a little bit more in depth about it. So rather than just like doing a sketch, think of trying to do a larger piece. 2 weeks. Is that really any better though? 2 weeks? I mean, yeah. Here's the thing. The sketches, clearly, I hope it's clear what I've been expecting for the sketches is just to see you play in a little bit. Cole submitted a number of small pieces. That's great. Some of you have done just a single one. Some of you got a little bit further into literature. The whole point of the sketches is to see you iterating through ideas and then bring in something that you found interesting throughout the week. Okay, let's talk about languages. Ideally, when you're working in any sort of language, regardless of whether you're learning Spanish and French or you're learning SuperClider or JavaScript, what's the key to learning a language? Yeah, what did you say, Bearcat? Okay. What did you say? Repetition, yeah. What else? It's about living in it and being in it. So I would really encourage you at this point, not much, 20 to 30 minutes a day in SuperClider. Just 20 to 30 minutes a day. So you're doing a little bit and touching it every day. Okay, that's going to help you start to feel a little bit more comfortable as you come back. You're going to look at stuff. You're going to be like, oh, yeah. I still have no fucking idea what's going on. But I'm starting to see where are the things that I'm confused about. Maybe I should set up some office hours appointments with Dr. Mead. This coming Monday, my office hours are not going to be valid, but I will hold in-person meetings with anyone who wants them Tuesday and Wednesday next week. Just send me an email. Happy to set up a meeting. Now, for this crit day 1, or essentially what is going to be like a midterm artwork composition, I'm expecting something a little bit big. Ideally, you're thinking about, is this some sort of piece that has no beginning and end and goes on forever? Is it something that changes over time? Does it have some sort of structure? What are the ways I can do that? We've started looking at routines and tasks as being one way that we could progress things in time. We've got things like the mouse, impulse, some other server-side scheduling, including like the LF noise, UGens. And here's the other thing I'm going to open up as an option. You can, alternatively, you can work entirely in SuperClider. Alternatively, the other thing I'll show next week, and I'll add this right now. Okay, so let me add this right now. How to record SE. So the other thing you could do is you could record out a couple of segments of audio from SuperClider, be they individual sound patches or textures, and then compose something together or develop something in a DAW of your choosing. And then you could actually produce a piece in a DAW. I'm happy with either option. My goal for you in this class is to see how can we use some of these methods and techniques in your ultimate creative process beyond this class. If you don't want to be in SuperClider as the only means of creation, I don't care, that's fine. If you want to just use it as a tool of something larger, then use it as a tool to get the kind of sounds you want and then bring it into something else. If you want to challenge yourself and stay in SuperClider, great. We'll talk about it either way. We'll have a great conversation that day and we'll kind of dig in deep with each other. So what are we expecting? Create a significant sonic artwork using the skills you have thus far acquired with SuperClider and in sonic programming. This artwork may be presented as a live work that you perform or a fixed work that is played back from a sound file or SuperClider itself. So you're welcome to bring your computer and set it up here and play on here. You're welcome to play on my computer. You're welcome to give a sound file. You're welcome to just give code that I'll hit enter on a new one. If you create a fixed work, please feel free to utilize a DAW to edit, mix, and master your content. This does not have to be a work fully realized within SuperClider. However, all sound should originate from SC. Ideally, if you really hate that, you don't have to. And then you can edit the sounds further. If you want to mix it with other sounds, like if you want to use some crazy SuperClider sounds and put it on top of an 808 or some sort of other bass that you feel really comfortable about, that's going to be fine for this first kind of major project. These are to be significant pieces that show engagement with the creative process as it relates to working with sonic programming. To that end, you should document your creative process, including ideas, tests, personal responses, iterations. Here's what I'd like. We're not going to actually have you go over any of this in class, but I want you to be able to have documented enough that you can talk about how did you develop this piece up. Specifically, what major roadblocks did you hit? What major problems did you run into and how did you solve them? What things made you want to throw your computer out of an 8-story building? What things were aha moments or happy accidents? And you're like, yeah. Okay, I kind of want to know your process a little bit. I want you to be willing to talk to the class about that. In addition, we'll do a regular short sketch for next week. Again, this is short. So over the next week, do a short sketch for Friday. We'll upload that to Moodle like we have been. Over the next 2 weeks, start to develop ideas for a larger piece. Knowing that next week, if you're like, fuck, I need to get going right away on recording in SuperCollider, come talk to me next week early, and then we can set up a time and I'll show you how to do that. Otherwise, first thing next week in class, we'll go over recording audio in SuperCollider as well as piping audio over to a DAW. We'll then talk about how to get audio into SuperCollider from a microphone if that's something you're interested in, as well as setting up effects chains. And then we'll finally talk about some cool processing capabilities, including the comb and delay UGens, which I just dream about in life. You need a sketch for next week. And I'd really like you to use a sketch dealing with, I'd like you to, for next week's sketch, I'd like to actually be a little bit more specific. Write a short work that encapsulates your synths as synth defs, then utilize language-side scheduling to launch and alter synths algorithmically. We are officially in week 7 of the semester. We are technically in week like 5 of the class because I was a jerk and had a kid. I'm sorry. I'm sorry. Questions? Cool. Jared. So the code just got pushed to GitHub, and I will, for those of you out in Zoom land, I'm going to stop. Thanks for joining us today. And I will